Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video shows how to calculate summary statistics for binomial distributions. Let's get started. So we have the same summary statistics that we can calculate for binomial distributions as we can for other distributions that we've seen up to now. So to start with, we need to recall some basic conventions of how we're denoting different variables. So remember that the lowercase letter n represents the number of fixed trials, lowercase letter p represents the probability of success in one of those trials, and q, the lowercase letter q, represents the probability of failure in one of those n trials. So with that in mind, let's look at how to calculate the mean. It's a very simple formula. We simply take the number of fixed trials and multiply by the probability of success. It's really that simple. That's the mean for the binomial distribution. The variance is calculated with a similarly simple equation. Here it is. We take the number of fixed trials, multiply by the probability of success, and then multiply by the probability of failure. Notice that we've got this expression n times p, which is just the same thing as the mean, and so therefore we can actually rewrite this as the mean times the probability of failure. Standard deviation, as always, standard deviation is just the square root of the variance. So it's no surprise how we're going to calculate that. We simply take the square root of the product of the number of fixed trials, the probability of success, and the probability of failure. We could also rewrite that as the square root of the product of the mean of the distribution times the probability of failure. Let's look at an example problem to illustrate these calculation formulas. So here we have a clinical test in which 34.2% of participants experience unintended vomiting when given the standard dose of a certain drug. So if we select 8 subjects at random and we treat them with the standard dose of the same drug, what's the probability that at least 6 of them will experience vomiting? Well, the first thing we want to do is just go into StatCrunch and get our binomial calculator out, and we can put into the calculator here the parameters for our distribution. So we've got 8 trials, the probability of success, 34.2%. Notice how we're defining success in this case. Success is being defined as experiencing unintended vomiting. So I know it's a weird way to success, but you can define it the other way, but then you're going to have to redo this percentage here to reflect your percentage of success, and then you might have to reinterpret the results you get out of here. And so in order to prevent that, we're just going to use what they give us here in the problem, 34.2%. That just makes it a little bit easier. After all, we are looking for the probability that a certain number will experience vomiting. So that's why we're defining this as success. I know it sounds weird, but that's what it is. So we could see here, we just put everything in, the probability that at least 6 of these 8 randomly selected subjects will experience vomiting is 2.2%. Note that this is the sum of all the individual probabilities from x equals 6 to x equals 8. So the question that we were asked was the probability that at least 6, that means 6 or more. So it's 6 and 7 and 8. And so if you just take those individual probabilities for those random variables and add them together, you get the total for what you see in StatCrunch. Now, what is the mean and the standard deviation? Well, we just reviewed that a moment ago. To calculate the mean, we just take the number of trials and multiply by the probability of success. So the mean for this binomial distribution, 2.736. Standard deviation, likewise, easy calculation. We just apply the formula and we get 1.342. These formulas are simple enough that they could have been coded into StatCrunch. I don't know why they didn't just code it into the calculator there. It's simple enough, but they didn't do it. And fortunately for us, because we have to do it by hand, it is simple enough to execute. So it's not much of an issue, but it would have been nice if they would have coded that into StatCrunch. Let's look at another problem that we've seen earlier. We looked at, in an earlier mini lecture, this problem with the Sureglass windows. And we used the 5% threshold to determine whether 5 contractors using these windows was unusual or not. Now let's do the same thing with the range rule of thumb, and we'll come up with a similar answer. So to use the range rule of thumb, we first need to calculate the mean and the standard deviation. So the mean is going to be the number of trials times the probability of success. The standard deviation is going to be the square root of the mean times the probability of failure. So here we have our mean and our standard deviation, and now we have the numbers we need to calculate our max and min usual values. So we take 2 standard deviations from the mean to find those values. So the minimum usual value is going to be given by 2 standard deviations subtracted from the mean. That gives us 2.12. The maximum is going to be adding 2 standard deviations to the mean. That gives us 6.52. Then we look at where's 5 in that range. 5 is actually inside that range of what we would consider usual values, and so 5 contractors is not unusual. Let's take a look at one last problem involving recognition rate. McDonald's has one of the most widely recognized brands in the world, 95% recognition rate. So a special focus group decided to randomly select 12 adults, and then we're asked to find the mean and the standard deviation from that group. Well, the mean, we know, is the number of trials multiplied by the probability of success. So we just take the 12 trials, 12 adults, and then multiply by our percentage, 95%. That's our recognition rate, and we get a mean of 11.4. Standard deviation, we're just going to take the formula for standard deviation and just plug in what we've got. Notice the 5% failure rate comes by subtracting the success rate from 1. So 1 minus 0.95 gives us 0.05. P and Q are always going to add up to be 1. So if you know one of them, you can get the other one. So we plug in those values here into this equation, and we get the value for standard deviation. Suppose we want to know the range for the usual number of people who recognize the McDonald's brand. Well, we can get that with the range rule of thumb. So the minimum value that we get, just subtract 2 standard deviations from the mean. The maximum value, we're just going to add 2 standard deviations to the mean. So there's our range of usual values between 9.8 and 13.0. So with this range of values, note that having all 12 members of our focus group recognize the McDonald's brand would not be unusual. And we wouldn't even think of that as unusual because with such a high recognition rate, practically everyone recognizes the McDonald's brand. However, if only 9 of the 12 recognize the brand, so there's 3 of them that don't, that would be unusual. And that makes sense. It would be unusual to have a quarter of randomly selected adults say they don't recognize the brand. Yeah, that would be unusual. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.